We use the law of sines to solve a triangle that is not a right triangle. Okay? We use this case of the law of sines if and whenever you know an angle. We use it when you have an angle and its side opposite. If you know an angle and the side opposite in a triangle, no matter what other parts that you have, you can solve for everything else. But in order for the law of sines to work, you have to have, well, a triangle, A, B, C. Capital letters are vertices, lowercase letters are the sides opposite. We talked about that before. But the moment you know an angle and its side opposite, that's when you use the law of sines. The law of sines is just some crazy looking ratio. All it is this. The sine of angle A is to its side opposite, as the sine of angle B is to its side opposite, as the sine of angle C is to, you guessed it, its side opposite. And as you went through these things before, as long as you had a side and its opposite, you would just reuse that bit of information to solve for the other parts. Because no matter what, if you have a side and its opposite, it doesn't matter if you have another angle or another side, you can use the law of sines to figure that out. Okay? If you don't have an angle and its side opposite, then we'd have to use that law of cosines. That's when you have the what we call the side angle side scenario, or the side side side, where you have two sides in the occluded angle, or all three sides. That's when you use cosines. We'll worry about that come Friday. Today we're going to talk about sines in such a manner that you guys have done in the past with one little extra part. Tomorrow I'll throw all the nastiness at you. Okay?
When you're not here.
Yeah, so you guys watch the video tomorrow. It's easy. Very easy.
The last time someone dropped a calculator in the middle of the video, it like scared all of us. Like, you just like look around the room and you'll see like someone jump, and then like a couple seconds later you'll see someone else jump.
That's funny. A lot of times in these problems, you're going to be given information. Gee, what do you think you should do with said given information? I would draw a lovely picture. Now, I would not draw a picture of like Santa Claus on a sleigh, but I would draw a picture of a triangle with the vertices labeled. And obviously, we can go ahead and assume not drawn to scale.
Are you sure?
Pretty sure. Okay. Thanks. Now, one of the other things I want you guys to get in the habit of doing is that once you get this far, right away, write down what are the parts that you're missing. Now, in this problem, I have two angles and one side, which means what else do I have to find? One angle and two sides. So I'm going to write down right away what I need to know. I need to find angle A, and little c. Gee, what do you think that accomplishes? And reminds you that if you find one thing, you're not done. There's two more to go. Okay? That's what it does. It's organizational, and it helps you remember what's left to find. Because too often that people just find one part, think they're done, they go, oh. So the next thing that I would always suggest that you do, once you know that you have to use the law of sines because you have the angle and its side opposite, always circle what you're going to use as the given information. Because I'm going to use that angle B and its side opposite, little b, to find both little a, and little c. Because I can find the angle A relatively easily. How? 180. Yeah, because last time I checked, there's only 180 degrees in a triangle. So we just subtract them out. So subtract that out, we got 103 that gives us 77. Subtract out the 28, it would leave us with what? 40, 49? So I have 49 here. And I'm going to write it down that I already found that. Okay? So now I go ahead and start writing out my algebra. I have the sine then of 28 is to its side opposite is to the sine of 103 is to its side opposite, little c. Remember, the sine of an angle is just some crummy decimal. And instead of writing out 4 decimal places or whatever, we're just using the letters SIN to represent it. When you have fraction equal fraction, what do you have to do? Cross multiply. Very good. So when I do that, I know that in time you're going to find these little shortcuts for this stuff. But for right now, I kind of go the long form. So c times the sine of 28 is 26 sine of 103. Remember, that's c times some crummy decimal. How do you undo multiplying by a crummy decimal? You divide by the crummy decimal, which means I just bring this one back. So that means my c value is going to equal that information. Okay? Please write down what you're going to put in your calculator like that before you do it. So make sure you're in degree mode. LeBlanc, your batteries didn't fall out since yesterday, did they? Okay. So just make sure you're in degree mode. And when you type this in, use the fraction bar. (26 sine 103 over sine 28) and hit enter. And I'm getting 53.96. Everybody else okay with that? Yeah. All right. Always remember, I like to go with 2 decimal places just because it's nice. And then I start over because now I also have to find little a. Yeah, always try to reuse the given information as much as you can. There's going to be a time with law of sines, law of cosines, that sometimes you might not be able to. You kind of have to take a leap of faith. But if ever you can, do that. Okay? Plus you'll have less rounding error and all that other junk. Is it 49? Now at this point, you'll probably recognize that your variables for both of these 2 parts of the law of sines were in the exact same position. Lower right-hand corner, correct? So you can kind of shortcut yourself and say, oh, all I have to do then is that A is going to equal 26 sine 49 over the sine of 28. Because it's going to wind up solving the equation the exact same way you just did, but just with a couple of different numbers.
41.80.
Yeah, that's what we got earlier, 41.80, because it's like 796, something like that. Yeah. So that gives you 49.80. 41. Thank you. So when I go for this one, I get 41.80, and now you're looking at your triangle going, okay, I guess. But all you can do really is when you go back here, we have 41.8. And this one was 53.96. Really, the only thing you can do a lot of times with law of sines style problems, or even law of cosines as we get there, is just to look at the relationship between the angles and the sides opposite. Remember from geometry we talked about the largest angle always has the longest side length, shortest angle, shortest side length, and so on. If that holds true, you're probably on the right track. Because there's no way of just verifying it for certain, by using Pythagorean theorem to double check your work or anything like that. Unfortunately, that's kind of all you can do. So that's it. It. Math. Okay. Vaguely remember this? Just trying to.
No.
Oh, I need to find which one was it. Oh, poop. What problem was it? Area. Oh, I forgot what number it was. Sorry, I drew a blank what number it was I was going to do. Sorry, I was on the wrong page, that's why. All right, same idea. In this case, you have one angle and two sides. I wanted to give you guys an example of both of them, of how you find angles versus sides. So I have angle B at 105, little b at 11, and little a at 5. What is this forcing you to find first? With angle A. It's forcing you to find angle A first because you kind of do. You have the set of B right away, but you have to figure out what angle A is because you have its side opposite. So you have to find angle A, angle C, and little c. Okay? Using angle B at its side opposite as that pivot, if you will, to set up to find angle A. So you write it out again. We have the sine of 105 is to 11 as the sine of A is to 5. Now there's a nice little trick that happens whenever you have, when you're trying to find an angle. There's a little less work that you need to do. If you cross multiply both parts here, you're going to get 5 times the sine of 105 equals 11 times the sine of A. Wouldn't you have to move the 11 back anyway before you find the angle? So whenever you find the angle, you only have to multiply that by that one denominator. So what you get is this. 5 sine 105 over 11 is the sine of A. And this is where using the calculator to your benefit, what's that? This is where you have to find the angle. What angle has the sine of this nasty decimal? So you go to your fraction thing again. Type it in. 5 sine 105 over 11 and hit enter. This crummy decimal equals the sine of an angle. How? Exactly. So this is where you use that inverse function. So you hit second sine of your answer. Error. So we get an error? Goofed.
Wait, so the upper number is from what?
Did you get that decimal? You have crummy decimal in your answer? Once you get that, then you just hit second sine of your answer. Second sine of the answer. Because you're taking what you're asking, what angle has the sine of that crummy decimal? Well, 26.04. The sine of 2604 is 0.43 and
So
change.
you wrote second, like to find the actual angle, you took second sine of what exactly?
Of that answer.
Oh, okay.
So that's if you're going from a side length
Oh,
to an
5
angle,
cents.
right?
Yeah, if you have to find the angle, the only time you have to hit inverse is if you're finding the angle.
Okay.
You have to use the inverse button to figure out the angle. Okay? That's how that stuff works. So that gives you your angle A at 2604. Now what do you do to figure out the last angle? Add them, subtract from 180. So when you add them together, you subtract from 180, you're going to get 4896. So we have 2604, 4896. And now I use law of sines one more time to figure out the missing side length of C. We just keep bouncing back and forth between these. Yep, you have it. And as you do enough of these things, you're going to recognize that you could probably write it out in one step without, having to list all of your steps each time. Because I'd multiply by the C, divide by the 105, because you can do the exchange-o, change-o on the diagonal. It was 4896, right?
Yes. I would check.
And that's giving me my side length of C. There's a lot of button pressing here for this stuff. What is it? No, it's like 229. $859. And then once again, you go back just to double check. Does the largest angle have the longest side length? Does the shortest angle have the shortest side length? Is the medium going with the medium? All right, so then you're probably okay. All right, one more of these, and I'll show you one other cool thing you can do with science.
So how did you know to do the inverse?
Whenever you're finding an angle, you have to use the inverse.
Oh, okay.
You only have to do that if you don't have like two other angles, right?
Yeah. Whenever you're finding an angle, you're using the inverse button because you're gonna get some crummy decimal equals the sine of something.
Oh, okay.
And that inverse idea, I want you to start thinking, what angle has the sine of this? What angle has the sine of that, cosine of that? Because that'll help us later on when we start doing, when you get to that. Or, sorry. You'll start to think of what, instead of saying inverse sine of root 3 over 2, because you won't have a calculator, you're going to ask yourself, what angle has the sine of, or what angle's sine is root 3 over 2, and so on.
That makes sense.
That's where we're heading. That's why I'm using that terminology. All right? Hold on. We talk. Please. So what happens a lot of times, you're going to get stuff like this. And it's going to say to solve the triangle. Excuse me. You have A at 140 degrees, little a at 5, and little c at 7. Why?
Because the largest angle goes with 5. And that doesn't equal the largest angle is supposed to go the largest side and C larger.
How do I know that A is going to be the largest angle?
It's only on 180.
Because there's only
140 is bigger than the
140 is bigger than, there would only be 40 units left, so.
What happens here is, I'm just kind of getting you guys in the idea of here, is sometimes things can go wrong because they will really hit the fan tomorrow with the whole 2 triangle idea. What this stuff here is that there is a possibility sometimes that if you're given, especially with the obtuse angles, if you're given an obtuse angle and the side opposite isn't longer than another side, you're done. No, triangle can't exist. Not gonna happen. All right. What? The triangle is not valid. Not working. Okay. Yeah, it's not found. Right. Now, tomorrow, what's gonna happen is that you're gonna get this possibility, dependent upon angle measures that you get. You could wind up with two separate triangles given specific values because of supplementary angles and the reasons of the unit circle, why sine can be obtuse and all this other fun stuff. But we'll talk about that tomorrow. One last little bit of this that I wanted to look at today, which is actually really easy, is using a silly formula for finding the area of a triangle. What did that stand for in geometry? This stood for side angle side. So, it stood for something like that. Side angle side meant you had two sides and what's called the included angle, the angle in between. Now, what happens is, in Algebra 2, we start to show you guys that there are other ways to find the area of a triangle. Well, the area of a triangle, if you know the SAS, if it is in this case, is this. 1/2 side, side, sine of angle. Yes, sir?
We won't ever be doing proofs again, will we?
Yes and no.
Wait, so yes or no?
You will be doing verifying of trigonometric identities, which basically is, it's not so much of a 2-column statement reason proof. It is what properties can you morph something into to change it to something else. So it is, in theory, it is a proof, but it's a different style, and that's still a few weeks away. Okay. So what happens here is, if you have this, what we call side angle side triangle, you can find the area of it by taking 1/2 the side times the side and the sine of the angle. For example.
Oh, cool. So you go like 1/2, 2 times 3.
Yeah.
Sine of 47.
Because if you draw this out, isn't that side angle side? Since that's side angle side, you can just fill in the blanks. The reason they throw this in here is because it's using sine, and you're looking at sides and opposites and stuff like that, even though it's more of a cosine problem, whatever. So if I figure out the area of this triangle would just be 1/2, 2, 3, sine of 47.
Yeah, that's 2.19.
Something squared. Areas and volumes are the only thing that I even really care about units. I don't know why I don't care about the rest of them, but for some reason that's what I care about. Not that I don't care about you guys.
You don't care about you.
Try that one. Like I said, if you get side angle side, it's this formula in your book is written out horribly, horribly bad. But just remember, it's 1/2 side times the sine of the angle. It's the easiest way to write it out is to write it out in terms of SAS. All right. I think I put the homework problems on the calendar already, didn't I?
Yeah, you did.
Let me check. I thought I did. do those.
So like you did before.